All right, we're diving into a molecule that's been hiding in plain sight for over a century. Methylene blue. It actually started out as a simple dye for things like blue jeans, but its real story is full of some deep contradictions. One of the guides we're looking at calls it a molecule with two faces. And honestly, that's the perfect way to describe its fascinating and sometimes pretty dangerous journey. And yeah, that is absolutely the theme for us today. It really is a molecule with two faces. On one hand, you've got a legit, life-saving medicine, a powerful tool for research, but on the other hand, it's hiding some really serious, even fatal risks. So our job here is to really unpack both sides of that coin. So that begs the question, right? What exactly is this stuff? Is it just a dye, a powerful medicine, or a dangerous poison? Well, the fascinating and kind of unsettling answer is, it can be all three. See, the secret isn't in the molecule itself. It's all about the context, how it's being used, and more importantly, why. So let's start with its first face, methylene blue as a helper. To really get this, we've got to zoom way, way in, right down to the cellular level, to see how it can be this incredible support system when things in our body start to go wrong. I mean, just look at its history. It's pretty wild. It kicks off in the late 1800s as a totally basic industrial dye. But it didn't take long for scientists to realize it could do more. And by the early 20th century, it was being used in medicine. The really crazy part, though, is what's happening now in the 21st century. It's had this total rebirth, suddenly becoming a hot topic in cutting-edge fields like neurobiology and, of course, the whole biohacking scene. Now, to understand why it's such a big deal today, we need a quick lesson on our cellular power plants, the mitochondria. Inside them, you've got this thing called the mitochondrial respiratory chain. The easiest way to picture it is just like a series of steps on an assembly line that's built for one thing, creating energy. Okay, so here's how that assembly line is supposed to work. The food we eat provides these little packets of energy called electrons. They get passed down the line from one protein step to the next. That flow creates a current, which spins this tiny molecular turbine. And that turbine's job is to just pump out ATP, which is the energy currency that powers literally everything your body does. But what happens if one of those steps gets blocked or broken, say from a toxin or some other problem? Well, the whole assembly line just grinds to a halt. And this is where methylene blue makes its entrance. It has this unique ability to just grab those stranded electrons and shuttle them past the broken part, essentially creating a temporary bypass to get the factory up and running again. So in this context, methylene blue is literally a helping hand. When a cell's energy production is failing, it can jump in and provide a quick fix. It keeps the lights on, giving the cell a chance to repair itself. This is the good face of the molecule. This is why people get so excited about it. But, and this is a huge but, that is only half the story. It's time to look at the other face of this molecule. Because that helping hand, well, it can become a very harmful one if it's used in the wrong situation. Okay, here's one of its most dangerous features. It's a potent MAOA inhibitor. Now, what does that mean in plain English? It blocks the enzyme that acts like the cleanup crew for really powerful neurotransmitters in your brain, especially a famous one called serotonin. So, what do you think happens when you suddenly fire the cleanup crew? You get a massive, uncontrolled pileup of serotonin. And we're not talking about a minor side effect here. This can lead to a potentially fatal condition called serotonin toxicity or serotonin syndrome. This is a full-blown medical emergency. And this is where that whole helping hand idea gets pretty ironic. Too much of a good thing, in this case, way too much serotonin, isn't a hug for your brain. It's a dangerous overload. And the risk skyrockets when it's combined with other things that also raise serotonin, like very common antidepressants. The source material is crystal clear about this. There are people who should never touch this molecule. If you have a specific genetic condition called G6PD deficiency, it can cause your red blood cells to literally be destroyed. If you're on antidepressants, the risk is incredibly high. And here's the real kicker for biohackers. If your cells are already perfectly healthy, methylene blue doesn't help. It just adds a bunch of unnecessary, harmful stress. So, all of this brings us right to the heart of the matter. Whether this molecule is a helper or a hazard, it has nothing to do with the molecule itself. It is 100% about the context. This chart just lays it out perfectly. The two completely different worlds of methylene blue. On the left, you have clinical use. The goal is clear: treat a specific diagnosed problem. The dose is high but medically supervised. On the right, you have the biohacking world. The goal is often a vague idea of enhancement. The dose is low, but it's self-administered. And the evidence? It goes from established science to just personal stories. The entire risk-benefit calculation just gets flipped on its head. And, even inside a cell that's actually struggling, it's not a magic bullet. This shows just how specific its job is. If a part called complex I is blocked, it can help. But if complex 3 is the problem, it does next to nothing. And just look at that last row. In a healthy system, there is zero benefit, only the potential for harm. It's like a key that only fits one very specific lock. So if you take away only one thing from this entire discussion, please let it be this. This is the crucial point, right from the source material. Methylene blue does not enhance a healthy functioning system. It is a repair tool, not an upgrade. The guide also gives us a number to hang on to, something that makes these risks a bit more tangible. Once you start hitting oral doses of 1 to 2 milligrams per kilogram of your body weight, the chances of side effects start to climb, and fast. For a lot of people, that's still a really small amount, but it marks the threshold, the point where this molecule shifts from being a potential tool to just a burden on your system. Okay, so after looking at both faces of this really complex molecule, the good and the bad, what's the final verdict? Who is this stuff actually for, and when could its use possibly be justified? So here's the bottom line, laid out as clearly as possible. Is it a powerful tool for specific, diagnosed cellular problems? Yes, absolutely. But it's just a temporary bypass, not a cure. Is it some kind of universal cognitive enhancer or energy booster for healthy people? No, it is absolutely not. And that final point is critical. This stuff requires extreme caution and a really deep understanding of what it's actually doing inside your body. And all of this leaves us with one last question to think about. Because really, the story of methylene blue is a perfect case study for the entire world of biohacking. Knowing about its two very different faces, its potential to both help and to cause serious harm, it makes you wonder, where do you personally draw the line between a calculated attempt at optimization and just an unacceptable risk?